which is a data warehouse solution on top of Hadoop. Hive gives us the liberty to use SQL syntaxes in the form of tables, in the form of views, databases, and many other constructs, which makes the life of a person coming from SQL background easy to adopt the complexities of MapReduce. So I'm really excited to go ahead, and I'm sure you must be feeling the same. The very first thing is, what exactly is Hive? In order to understand the true meaning of Hive, let us take a step back and revise what exactly are the challenges of current data. Currently, we live in a world where there are lots of data, extremely high in volume, and very diverse in variety. On top of that, there are further challenges like velocity of data and veracity of data, the value which we can generate out of data. In order to deal with that large amount of data, we have got a very powerful framework in the form of MapReduce. But this MapReduce has its own set of difficulties. It's very robust and it has become very mature. But the problem is, it's very time consuming to write a MapReduce application. Making changes to MapReduce applications are also tedious. We want to leverage the power of MapReduce, but we would also like to make the development effort and time very quick. Hive is that SQL layer on top of MapReduce. So basically, if you are coming from a SQL background, any RDBMS background, it will be very easy for you to adapt Hive. You will be taking advantage of the SQL queries like select, create a table, create a view, a database, select particular columns, apply where clause, perform group by operations, perform join operations. So it is basically a SQL layer. Whatever you write in the SQL gets translated to the MapReduce internally. So this is the true advantage of working with Hive. That said, I'll just highlight some of the important points. Basically, Hive is built on top of Hadoop. It was developed by Facebook in 2008. It gives you a SQL construct or dialect on top of data present in the distributed file system, what we call as Hadoop distributed file system. It will use SDFS for storage, and it will use internally MapReduce for processing. These days, there have been further advancement, and we can use Spark or Tez also instead of MapReduce. The first important concept of Hive is the database. A database in Hive is essentially a collection of different tables or different views. You can create a database using this syntax, create database. Or if the database, you want to check, like if the database exists before you create it. So you can optionally add a clause like if not exists. In this case, if the database does not exist, it will be created. Things will become more clear if we take an example. So let's quickly jump into one example and see what are the different analysis we can perform with Hive. I have got a data set called as geolocation. It contains different fields like truck ID, driver ID, what was the event, what was the latitude, longitude. So basically it's a sensor data. Whenever a truck is moving, I get all the information like who was driving the truck and what was the number of truck and what was the city, state, many other things like velocity as well. We would like to take this data set as an example and perform some analysis on top of it. For this purpose, I am using the Acadgild virtual machine, which is a Unix operating system, CentOS, and I'm using a software MobaXterm to perform SSH, that is to log in into that machine. Make sure that your virtual machine, if you go to the settings of the virtual machine, inside the network, you are using host-only adapter. In this way, you will be able to perform the login from any other client. You can use Putty or any other software to do the login, and it's very simple. You have to just go to the sessions and provide the details like what is the IP address, and the port is 22. This IP address you can fetch from the virtual machine. Like if you go inside, the password is Acadgild and username is also Acadgild for our virtual machine. In a while, terminal will show up, and in the terminal you can type ifconfig to see what exactly is the IP address. So you see, this is the IP address of the machine which we want to connect to. In order to work with Hive, you have to make sure that all the services are running. Like if you type JPS, your resource manager, secondary name node, data node, node manager, and name node must be running. If they are not running, you can use a start all.sh. This is the syntax if you want to start the services. In my case, every service is running, so it will essentially not perform any startup activity of any of the service. The other important aspect is, in order to work with Hive, you have to make sure that your MySQL server is running, which you can check sudo service mysqld, and you can check the status. So it will ask for the password. In my case, it is running. If it is not running, you have to make sure that it is started. So you have to type start and then press enter for the same. After these things are done, you can directly jump into action by typing Hive. Once you type Hive, you will be redirected to this Hive shell. This is the Hive command line interface. From this command line interface, you can perform different Hive operations. And we are going to take a look at those operations. And before we take a look, it's important to see what exactly are we trying to do. The first statement which we are going to trigger is, we are going to create a database called as a demo. Then we are going to go inside that database using use. After that, we are going to create a table. Let us try to understand the different syntaxes as well as the different operations we are performing while creating the table. This is a table whose name is geolocation. We have tried to create different columns. Basically, these columns are same as the fields you will see in the Excel file. We have taken all to be string. Our intention is to load this particular CSV data. So we are using the OpenCSV Survey. Survey is the factor which decides how your data is going to be encoded or decoded. So we are going to use OpenCSV Survey. There are different other serializers and deserializers called as Survey available in Hive. This is one of them. In the Survey properties, we specify what is the separator character. That is, which is the character which separates two fields. In our case, it is comma, because it's a CSV file, comma separated values. Quote character is a double quotes. Whenever we receive a double quotes, it will be considered as a quote character. Content inside the double quotes will be treated as a single value without double quotes, obviously. And backslash is considered to be the escape character in our data. After all these definitions of different separator and quote characters, we also specify in the table properties, like we are going to skip the first line of the data. In the data, you will see the first line is not the data, it's the header, which we don't want to read, which we don't want to analyze, because we want to analyze the rest of the data. So we can specify that we want to skip the first line from the header. After this, the table will be created. Meanwhile, in our local, if you type the pwd, that is the present working directory, we are working inside this particular location, which is home Acadgild Hive demo data set. And you will see there is a file called as geolocation.csv. In order to work with Hive, the very first thing which we have to do is we have to move the data file from the local file system to the HDFS. This can be done by using Hadoop fs-put command also, but there is one quick and easy syntax for the same. The syntax goes like this. If you try to decode this statement, it says load data. We are trying to load some data. We are getting the data from the local file system. This is the input path, the whole path of the data. And we are going to load this data into the table demo.geolocation. So this is the table in which we will be pushing our data. Let's execute these things to gain more understanding. So first of all, I'll just do copy paste and you will be able to understand what exactly is being done. So just paste it. So the database, if it does not exist, it will be created. And now I am inside the demo database. One more interesting thing is Hive has got some configuration variables. With the help of one configuration variable is hive.cli.print.current.db. If you want to see the value, just press enter and you will see it's false. This is the default behavior. Let's make it true and you will see the difference. Once you make it true, the current database will be reflected in the Hive shell. This makes it easy to work with databases and in order to understand that in which database you currently are. Let's create the table now, the geolocation table. By this definition, this is the DDL, data definition language. Okay, so table has been created. I'm clearing the screen using Control L. And now if you want to see the list of tables created, you will see a geolocation table has been created. If you want to see the description of the table, you will see describe and then you will type tables. Hive is completely case insensitive. It doesn't matter whether you write this with caps on or caps off. So, sorry, my bad. It has to be describe table. Okay. This is not the case. My table name is geolocation. Okay. So this will give you the description about the table. In the process, we learned something interesting. If you type anything which is syntactically incorrect or if the table is not found, you will get semantic exception. Like I said, describe tables, but there is no table whose name is tables. So you will receive some exception. This kind of handling of syntaxes is performed by the Hive. Whenever you write any incorrect expression or whenever the table is not found, you will receive the error immediately. So we are able to describe the geolocation table which we just created. We will come back to the description with more extension in a while. But before that, let us try to load this table. You see, after this command is executed, you will see on the screen loading data to a particular table. In our case, it is demo.geolocation. Let us first see how many records are there. So we'll write select count star from geolocation, whatever is the table name. Let's see what happens. Once you type this statement, something starts. This is essentially a MapReduce job. You don't have to write a MapReduce job for this purpose. Your SQL syntax, whatever you wrote here, select count star from the table, gets translated into the MapReduce job, and that job gets executed by the framework. This is the real power of Hive, which gives you an abstraction over the MapReduce, and it will give you back the result on the screen. In our case, the result is 8,000. You can also compare the same with our data set. This is our data set. This is row number 1. And if you go back to the bottom, it is row number 8001. So the actual data contains 8001 record. Since we are not reading the first record because it is a header, so the actual data is only 8,000 rows. You can perform many other SQL operations, like if you want to see all the data, you can simply write select star from geolocation. Since there are lots of records, you can limit 10. This will give you the 10 records present in the table. You will be having a tabular format for the same. Now, one thing is what we are interested in. There is an event, like whether the truck was running normal or it was over speed, or what was the behavior, what was the event. We would like to see how many such events have been there. Like how many incidents of normal, how many incidents of over speed was there. If you're coming from a SQL background, you will be easily absorbed by the fact like group by will help us in this case. What we can type is, we can type select event and count star from the table geo location, and we can perform a group by event. So for every event, this will give us the number of occurrence of that event in the data set. Meanwhile, we will discover that there are where clauses also available. There is order bys, and there are joins also possible with Hive. We will take one more example for the same. Okay, our MapReduce job is still running. And now it has completed, and you will see that for different events, there are different number of incidents. Like lane departure, there were 152 such incidents. Normal, there were 7,543 such incidents. So you will get number of incidents for different events from the data set. How easy is it to work with Hive, isn't it? The next thing we are going to talk about is, let's say, where clause. I would like to take all the events associated with the truck ID A54. So what we'll write is, we'll write select star from the table where truck ID is equal to A54. This will give us all the incidents associated with the truck A54. So you can perform a filter using the where clause. Let's get ahead and talk in detail about this particular table. This table has got a data set geolocation.csv, which was taken from the local file system. And we covered in the beginning that the data of the Hive is stored in the HDFS. So where is it stored? How to view that? Very simple. We have seen the description of the table. We can write disk, and then we can write formatted, and then you type the name of the table. Once you type that, you will get lots of details associated with the table. One such detail is this particular location. This is the location where the table data gets stored. The structure is something like that. There is a directory corresponding to the database, and then there is a directory corresponding to the table which is present inside that particular database. All our files will be inside this particular directory. One interesting point is you can access the HDFS using Hive. Like if you want to go to Hadoop command, the Hadoop command to view this particular directory will be Hadoop fs-ls. Type the location and press enter. If you receive any warning, ignore this at this point of time. You will see This is the file present inside the directory. The name of file is geolocation.csv. This is the same file which was there in the local file system. Optionally, if you want to access the SDFS from inside the Hive, just copy this path. Go inside Hive and type the command dfs -ls. So dfs is something which stands for Hadoop fs. This is the directory of SDFS. Semicolon to enter it, and see, this is the same file present in the SDFS on top of which we are running the Hive queries. So Hive gives an abstraction, it gives you logical tables, it gives you databases, on top of which you can perform your SQL queries to get the results you are looking for. I hope this video gives you a quick start about Hive, how you can process diverse data set. We took an example of CSV data set, but in practice, there can be different varieties, including ORC formats, Parquet formats, text files, JSON files. So Hive has got the capability to deal with all such files. And then there are many other interesting features of Hive. And I'm sure this video gives you head first into the Hive domain. Thank you.